Katika somo la leo tunaenda kuangalia sequences of functions, that is in real analysis, sequences of functions. Karibu tena kwenye YouTube channel yangu. This is Filipino explaining. Kama wewe ni mgeni katika YouTube channel hii, please make sure you have subscribed na usahau click bell notification so that punde tu nitakapokuwa na upload video mpya utakuwa unapata notification. Tuendelee kusoma pamoja, kujifunza pamoja, unanifundisha nikufundishe. Hope umeshafanya hivyo, nashukuru sana. So we can start. Here's a problem. Show that the sequence of functions defined by fn x is equals to x raised to power to n on the interval -1 1 converges pointwise. So before we solve, can have a definition here. Definition for sequences of functions: that for every n, small n, that belongs to n, let f from s to real space R be a function we say the sequence fn n to infinity n is equals to 1 converges pointwise to f from s to real space R if for every x that belongs to s we have fx, which is equal to the limit of fn x and tends to 0 where fn means sequence of function. So kufikia hapo tunaenda moja kwa moja, after you have seen the definition, tunaenda moja kwa moja the solving the problem. So solution: our fnx is x raised power to raised to 2 power, and fnx is equals to x raised to power to n. So for x is equals to 1, for x is equals to 1, remember now we shall be plugging in these values in the interval -1 and 1 so that we can see if the given function converges pointwise to the given interval. So for x is equals to 1, the limit of n of fn x as n tends to infinity is equals to the limit of x to n. Remember, fn x is x raised to power 2n, so n tends to infinity. Are we there? And this becomes the limit. So our x is 1, so we write limit of 1 to n. Remember, n tends to infinity, so it will be 2. It will be limit of 1 raised to power 2 times that one, infinity. 2 raised to power 2 infinity, as n tends to infinity. And therefore we have 1 as the answer. Remember, any one, a number 1 raised to any number, a number 1 raised to any number is equals to 1, so it's 1. And thus you can say that thus fx is equals to the limit fx n to infinity. Hence, the sequence fn converges to 1. With there, after that, we move to for x is equals to negative 1. Remember, we started with 1, now negative 1. And so for x is equals to 1, negative 1, the limit of fx as n tends to infinity is equals to the limit of x to n over n to infinity, not over, but the limit of x raised power to n as n tends to infinity. Yes, tends to infinity. Then we substitute now in the values. Limit, what's x now? Negative 1 raised power to n, which is infinity. Remember, n is infinity. Are we there? As n tends to infinity. And therefore this gives us approximate, not equal sign, but an approximate to 1. The answer is approximately to 1. The answer is approximately, the answer is approximately to 1. Thus, fx is equals to the limit fn x as n tends to infinity converges. And up to that point we are through. So it's very easy, as you can see. Very easy, very simple. As you can see, you just plug in where there is x, you just find the limit, and you substitute x in the equation, f and x, with the values given in the interval. For example, in our case, we are given -1 and 1, so we substitute the 1, then -1, and we can see that the sequence fn converges. The sequence fn converges, and so we have shown that the sequence of functions defined by fn x is equals to x raised to the power 2n on the interval -1, 1 converges pointwise. And it's also good to note that in the problem that you have worked out, it's good to note that for all other x, the sequence fn of x does not converge. For all other x in this problem, the sequence fn of x does not converge. And up to that point, I can say nice time, and thank you, asante sana kukutazama. Thank you so much for watching. Tukutane wakati mwingine kwenye somo jingine ambayo itakuwa kwenye video nyingine. Bye bye.